Swayam Prabha. Digital India. Educated India.
So our second talk for this session is coming from IIT Bombay, and Ms. Neelu Thomas is the presenter for this talk, and the title is Evaluating the Activity-Based Transport Emissions through Transport Model Split Optimization Model based on Travel Behavior. With that, I'll hand it over.
So, I'm Neelu Thomas. I'm a transportation planner doing PhD under Professor Arnab Jana and Professor Shantanu Bandhavedi at IIT Bombay. So today I'll be presenting on the topic evaluating the activity-based transport emission through a transport model split optimization model based on travel behavior. So the transportation sector is very crucial sector for sustainability of a city, considering it has a share of one-fifth of the greenhouse emission share is for the transportation sector. And among that, passenger transport in urban areas have a higher share, and the share of different modes, transport modes, such as walking, train or car, it will be different. And it will be also different based on the activity participation. In daily life, we do multiple types of activities. Let's say work, we might be doing grocery shopping or a recreational activity. So the mode choices varies for this kind of activity participation, and the emission also varies for such activity participation. So we are trying to evaluate the activity specific emission using a transport model split optimization model. So go to the model. Let me just explain the problem first. So if you consider an urban area or a regional boundary, we'll have different types of supply. Let's say auto rickshaws, cars, train, or even walking, bicycle. So we have different types of transport modes, and we have different types of demand entity. Demand entities are can be individuals, like we can just consider each individual separately, or maybe we can group them based on this socioeconomic index, or maybe in this case we are looking into the activities, different types of activities, how people are going with that. Let me just introduce a transportation model first. So because you are from different areas, so transportation model, there are some existing models specific to mode choice analysis. So those are statistical model which are specific to the demand entities, or which I can say each individual. So in this case, in such studies, they have identified transport cost and similar kind of attributes specific to the mode or the individuals cost, how they choose the different modes. So I'll go in deep into the different attributes. So if you consider just the supply, so we have a demand which is satisfied by each of the demand transport modes to satisfy the different activities, and all of these transport modes have a cost, like we are considered in the terms of passenger kilometer, so cost per passenger kilometer, and also all these modes have different characteristics. Let's say how much distance we can travel, how much time it might take to travel a distance, or whether that transport mode has last mile connectivity, or how is the crowding in that particular transport. So basically there are different characteristics specific to the transport modes, and there are some characteristics specific to demand. So now here we are seeing the demands will have a total demand in their daily life, which is represented in terms of FD, and there is a limit, like the desirable limit AIJ, which is like let's say I'm considering a mode characteristics like travel time. So I might have a like desirable limit in a day. Like let's say if I'm going for work, I might be willing to travel 2 hours in a day, like to and fro. But sometimes if I'm just going grocery shopping, I might not be willing to travel more than 30 minutes. So there will be a limit to such transport mode characteristics, which is represented in terms of AIJ. So if we look in specific into this relation between the supply and demand, we can see the sum of the total demand will be satisfied by different transport modes, and which is represented in terms of FIJs, and can see the total uh, passenger, or sorry, mode characteristics can be evaluated based on the flow, such as let's say if I have a limit, again travel time, I know how much travel time I take per passenger kilometer, and if I know the values of this each of the FIJs, I can calculate the overall limit for the then like I already said, we have a desirable limit. So the desirable limit also can be evaluated based on our sample data for a city. Okay. Now let's consider for some modes. If we consider public transport, sometimes it has a supply limit. Similarly, some for active modes such as walking or bicycle, we might not be able to travel in that mode beyond a limit. So we have to identify what is the demand of the supply. So in that case, we again use the sample survey data to identify the limit of such supplies. And we have cost for each of the transport mode, which also we can evaluate based on the FIJs. Now coming to the model, so what we are trying to do is we are trying to estimate the model split based on the objective function, which is to minimize the overall travel cost. Again, I'm repeating, why we take the cost as the major objective function is that in the previous existing transportation mode studies, it is shown like a cost is one primary reason how people choose the transport mode. So we get that as a like objective function. Other we have constraints such as entity flow constraint, mode flow constraint, mode characteristic parameter constraint. So coming to the entity flow constraint, it is nothing but we are saying if some group, let's say work trips as a demand for a particular value, it should be satisfied by this modes. It can be distributed anyway, but it should be satisfied by all this mode, or at least some of the mode. And mode flow constraint is, as I told, for active modes or public transportation, there can be a limit. So we also have to consider that limit. And as I told, the mode characteristics parameter constraint, like travel time or crowding possibility, such thing. So based on the whether it's direct scale or indirect scale, it should be within the limit. So coming to the framework, if we have if we select a region where we are where we are thinking to study our model split as well as the emission, so we have to identify what is the kind of supply there we have there, like different mode alternatives and the characteristics specific to them, and we have to identify what kind of demand we want to focus on. In this case, we are focusing on the activity types, and from there we have to make the matrices specific to the mode characteristics and the three types of data we are focusing on is the desirable limits and total demand of each entity and the limits of active modes and the public transport. So once we have this, we can, based on the equations, we can do the optimization model where we can get the model split. So we took the study area as Mumbai and we did a sample survey there, and we found based on the sample survey how is split. I'm not going into detail to the numbers now. So our demand entities was activity participation. We can look into the like types of activities in detail, like work, school separately, or maybe we can look, group them into whether they are mandatory, maintenance, discretionary, or what kind of activities they are. And the type of supply characteristics we looked at, the cost, timing, crowding possibility, traffic sensitivity. We can add, we used all these supply characteristics, and based on our model, what we found is this table, which where we are showing the model's supply flow in percentage. Now we can see the total model split is highest for work trips, and among them the private vehicle have a higher share among them, and similarly for recreational trip, the walking has a higher share. So we could find the difference how in demand, like type of activity and type of mode, how it was varying. So this is just the model split. Based on this model split, we could identify the emissions. So what we found was like there's something around 1.8 million kilogram of carbon dioxide emission in this Mumbai city. But I'm not focusing on the numbers. I would, like, as an urban planner, I'm more focused on the how it is distributed among different modes and different activities. So based on that, we can see some of the major types of gases and PM emissions are highest for the bus transport, and some other like CO and HC is highest for the two-wheelers. And two-wheeler is highest if you consider in developing under the share of two-wheelers are high, and the emissions are high in, at least for some of the types of emissions, it's higher for two-wheelers. And if we consider types of activity, we can see again the mandatory trips or activities like work or school trips have a higher share for almost all the types of emissions. But that is all again because of the higher share of mandatory trips. So yeah, so this is the result we found. Now coming to what we identified. So this is a new model, as I explained. So I already explained there are existing models which are demand specific, but they are mostly statistical models, which most of the time the policymakers could not understand what is happening with the values. So we are focusing on a model which is concentrating on the demand and supply, and where the values can be understood by the policymakers and they can bring a change. How they can bring a change? Because this has addition, like application of this model is beyond what I showed. Basically, if I add a new mode to the city, let's say we are adding a monorail to the city, or if we are removing a paratransit like a auto rickshaw or something, how the model split is going to change, and by that how the emission is going to change, we can identify that. And again, if we change some of the characteristics, let's say if I'm imposing like if the government is imposing flexible work policies, how the overall the model split selection might change, because the crowding is decreasing, the traffic is decreasing, and based on that, the emissions also will decrease. So that are the major findings and contribution of this model. And why I specified the heterogeneity, because the existing demand based models are not very much like giving appropriate or values or findings specific to heterogeneous society like India, because the socioeconomic as well as the model modes existing in India are very complex, and they are finding it difficult to find a solution for that. So our model is showing us a better result based on the findings. So thank you. Any questions?
So thank you. Any questions for this speaker?
Oh, you had a bunch of supply, demand characteristics. I just want to understand, how did you incorporate that information? Is it based on the
Demand characteristics.
yes?
Uh,
Like if it's like there was something like if you want to go to school, so it's mandatory or urgent. Like that. So
oh, okay. all the work and school trips are mandatory. So it's based on some literature, it's termed mandatory because it's something which people have to do. But something like going to shop for grocery shopping or hospital or getting something for home for repair, something like that. All those are maintenance trip, which are not like they are like they should be done for living, but it's not mandatory to be done. And there are discretionary trips which are like optional, recreational trips, or you're going for a party, social event, or such are the option which can be avoided if required. So we can't ask people to avoid this, only that we can change some of the impose some of the policy how people can use it differently.
Any other question?
Yeah, I wonder if the parameters of supply is less than the parameters of demand, because they show us you have the M is greater than N.
Sorry,
You see?
I didn't.
Yeah. Can you show us the slide? Yes, that one. At the bottom, you have I is equal to M for the supply, and demand I is equal to N, right?
Yeah.
And you show us that the M, if you look at the parameters for the next slide, M is greater than N. So do you
Yeah.
have any, you know,
What this can be different, like M is the total number of modes existing in a city. So for Mumbai, we had something around 11 options, and M can vary for our problem statement. For example, in this case, we are looking into the activity types. So if we group it, it's just 4. If we are considering in detail, it's something around 10. So if I'm grouping them based on socioeconomic index, again, we made an index and we grouped into 4 categories. So it will be the M will be 4 in that case.
okay, but does it mean that the constraint M is always higher than is larger than N?
No,
No,
No.
that's a
No,
constraint. Okay, secondly, you don't use pinch technology for what I think
No.
it is more in a superstructure model already. Is that right?
yes.
Mhm.
So we tried to apply pinch. So one of the major problem with applying pinch in this model is that the multiple characteristics of the mode types. As we told, it's just not cost. We can't just consider cost because people are not looking into the cost. People want convenience, comfort, all such things for selecting a mode. So that is why we might go to the pinch technology later sometime, but right now we stick to this method.
Okay, thank you.
So let's thank the speaker.